All right, everybody, welcome. My name is Miss Griffith, and as promised, I'm going to solve 10 problems for you on projectile motion to help you review for your test on January 16th. These are 10 problems you were given in class on January 4th, 2019. If you weren't here, make sure to pick one up. But this series of videos will walk you through 10 problems that should help you thoroughly review the projectile motion aspect of your test. I apologize in advance for the poor quality of the video. This is my first time doing anything like this, so for ease and speed, I've just set up a whiteboard, and I've got a marker and the problems here to solve. So number one is where we're going to start, and number one tells us that a ball rolls off a desk at a speed of 3 meters per second and lands 0.4 seconds later. We want to know three things about that ball. A, how far from the base of the deck does it land? B, how high is the desk? Sorry, not deck. And C, what is the speed and angle of impact? So the very first thing I should do is sort of visualize what's going on. For me, that's usually a pretty poor drawing. Here's my table, here's the ball, it's going to be falling down. I'm sure you all can do much, much better than this. You all know this is not my strong suit. But that sort of gives me at least an image of what's happening here. And then I'm going to make a list of my variables. So I have my x and my y components. In the x direction, I know always that a is 0 meters per second squared. There's no acceleration in the x direction because there's no force acting in that direction. And according to Newton's second law, no force means no acceleration. All right, and then I have a equals negative. The negative, because I'm saying the down direction is the negative direction and the up is positive. 9.8 meters per second squared. That's my acceleration always in the y direction unless I'm on a foreign planet or the problem states otherwise. So then a few other things that I have here. I know that my initial velocity in x is the same as my final velocity. They don't change because acceleration is 0. And it tells me in the problem that the ball rolls horizontally off the table, so that value here is 3 meters per second. If the velocity is entirely horizontal, that means the initial velocity in the y direction is going to be 0 meters per second. And then I have one more piece of information. Remember, that's the Romeo and Juliet piece that can go back and forth. I'll put it down here at the bottom, and that is that t equals 0.40 seconds. So now I'm going to go about solving part A, which asks me how far from the base of the desk. Now, how far clues me that I'm looking for something measured in meters, something like a distance. So I know that I'm going to be solving for delta x. All right, well, in looking at my equations, I have several that I can use to plug this in. I have a v, I have a t. So I'm actually just going to use my equation delta x equals vit plus 1/2 at squared. And I can go ahead and eliminate a little bit of this. One, I know that a is 0. So this whole term is going to become 0. So I'm going to just go ahead and erase it. I don't have to worry about it. 0 times anything is 0. And just solve it this way. Now my initial velocity in x, remember, is the same as my final is the same as 3. Never changes. So my delta x is going to be 3.0 times 0.40 seconds, which is going to give me 1.2 meters. And I can see on my sheet that that is the correct answer for part A. Part B asks me how high is the desk. Again, how high tells me I need something in meters, a vertical distance of sorts, so I'm looking actually for a delta y this time. I'm going to use the exact same equation, but this time different pieces will cancel based on my y values. So viyt plus 1/2 at squared. In this case, my viy is 0. So this term is going to cancel, or rather be eliminated. So I'm left with delta y equals, I could fill in 0, but 0 times my 0.4 is just going to give me 0 back. So my only relevant term here is 1/2 at squared. Solving that, I'm going to have 1/2 times a, which I know is negative 9.8, times t, which is 0.40 squared. When I type that in to my calculator, I get a value of negative 0.78, I'm going to round that, meters. Now, you may be confused about what this negative means. Remember that negative gives me the direction in the vector piece. So I know that the ball is falling down from a positive position to a negative position, or rather decreasing in position. So the negative doesn't mean I did the problem wrong. I'm okay. It just means that the ball has fallen negative 0.78 meters, or 0.78 meters down. This tells me that the desk itself is 0.78 meters tall. And I'll see that that's the correct answer for part B. Let me erase what I've got now so that I can do part C. I'm going to keep my variable issues up here and add on what I've gotten, just so I'll have this relevant information before I erase it. And then let's erase. Alright, so I'm looking at part C now. Part C asks for the speed and angle of impact. Speed and angle. So I know I'm looking for some sort of velocity piece, and I'm also looking for an angle theta. Well, I know that VI equals VF in the x direction is always Vx, so my Vx continues to be 3.0 meters per second. There is no acceleration, there's no reason for it to have changed, and it has not. Now that's my Vx final, so that's my final speed in the x direction, but what I need to figure out is my final y velocity. So to do that, I'm going to use my equation Vf equals Vi plus At. If you're a little confused about where that's coming from looking at the front of your sheet, remember that actually comes from A equals delta V divided by delta T, which we can rewrite as Vf minus Vi over delta T, and solve for Vf to get here. If that's confusing, pause the video for a minute and try to walk yourself into that A times delta T equals Vf minus Vi. So moving that Vi over, I get this equation to use. So then my Vfy is what I'm looking for. My initial Viy was 0 plus negative 9.8 times 0.4 seconds gives me a Vf value of 3.92 meters per second. Now that's not my final answer. That's my Vfy. So I have my Vfx and my Vfy. To figure out total Vf, I need to do the Pythagorean theorem. So I know that I have 3 as my Vx, positive 3. And then I know, pardon me, that should be negative. Hope you caught that. That I have negative, or down, 3.92 meters per second. And what I really want to solve for is the hypotenuse and the angle theta. So in order to do that, I'm going to say that the tangent of theta equals the opposite, which is 3.92 divided by 3. In my calculator, I need to do the inverse tangent of 3.92 over 3, which is going to give me rounded 52.6 degrees. That means that this angle here is 52.6 degrees, and as designated on the sheet, that is below horizontal. So my final speed is, well, I don't have that value. So to figure out my final speed, my very last step, knowing that this is a right triangle, I can do the Pythagorean theorem. So I'm going to have 3 squared plus 3.92 squared. Solving for that in your calculator and rounding, I get 4.94 meters per second. So my final answer is going to be 4.94 meters per second at 52.6 degrees below horizontal. And that is the answer to part C. Next up, we will do number 2.